Okay, we're going to write an algorithm to remove the adjacent duplicates in a string, and we're going to do a recursive solution. So if we had a string azxxzy, what we would want to return is ay, where we've removed the x's, and then the next round we would be removing the z's to return that ay. So to do this, we are going to kind of loop through iteratively and look for adjacent duplicates and get those removed, and then we will go recursively until we have no more adjacent duplicates. So at first pass, we would have if we started with azxxzy, then after the first pass, we would end up with azzy, and then go back into the function and remove those z's, and then we'd end up with ay. Okay, so let's go ahead and write some code. It's going to return a string. Just call it remove dupes. And it takes a string. Okay, so I'm going to be using string length a lot, so I'm going to go ahead and store it in a variable. And we're going to use string builder to build our string, and then we'll convert it into a string afterwards when we return it. Okay, so and we'll do some quick little checks. If n equals 1, then we know we can just return the string. And if n equals 0, then we can just return a message, no characters or some sort of meaningful message there. And then we want to first put the first character of the string into our string builder to start. So if n is greater than 1 and string at 0 does not equal string at 1, then we're going to append that first character. So that when we go through our while loop and check, we don't have any issues with going out of bounds, so that we can check both sides. Okay, so we need some sort of counter to keep track of our number of iterations. So while I is less than n minus 1, because again, we don't want to go outside the bounds of the string because we have to look at both sides of I. So while that is the case, we're going to do our test and see if string at I does not equal string at, string at I minus 1, and, so we're going to check both sides, and string at I does not equal string at I plus 1, then we're going to append. So temp dot append string at I. Okay, and then we would increase I, and that is our while loop. And that will run through each time. And then at the end, we need to append that last character, assuming that it is not a duplicate. So if, let's make sure the temp length is not 0, since there's always a risk that we didn't append anything. Temp length is greater than 0, and string at n-1, the last variable or the last character in the string does not equal string at n-2. Then we've got temp append string at n-1. Okay, and then here's where we'll make our recursive call. As long as the temp length is not equal to the string length. So if the string we passed in and the temp are the same, it means we didn't have to remove any more duplicates that round. So we would, at that point, be returning the string and not going into the recursion. So if temp length does not equal string length, then we are going to return remove dupes, and we want to send in our temp. We have to convert it to a string. Okay, and then if we end up not needing to go into the recursion, it means that we're done removing duplicates. So we would just return temp to string. Okay, so that should take care of it. So let's go ahead and run through the code and test it out. So if we have A, Z, X, X, Z, and Y, let's number them. And we're going to keep track of N. We're going to keep track of temp and I. All right, I think that's all of them. And so we go in, and N equals string length, so ends at 6. And string builder temp is created. So if N equals 1, which it does not, if N equals 0, which it does not, if N is greater than 1, which it is, and string at 0 does not equal string at 1, which is true, A does not equal Z, then we're going to append to temp. Okay, so temp is now an A, and then I is 1. So while I is less than n-1, so that is the case, if string at I does not equal string at I-1, it does not, and if it doesn't equal string at I+1, which it does not, then we're going to append to temp. So temp is now, we'll write it in a new, temp is now AZ, I++, I is 2. So now we go in, if I-1 and string at I+1 are not equal, well, that fails because X is equal to X. So all we do is I++, and I is still less than n-1. And we go in and we're doing if string at I and if string of I does not equal I-1 and I+1, which it does, so that fails. I++. And now we look at position 4, and 4 is still less than n-1. So we go in and we say, is string at I equal to I-1 or I+1? And it is not equal on both sides. So that means we're going to append the Z and I++. Now we go in, 5 is not less than n-1 because n-1 is also 5. So we get out of our while loop, and now it says if temp.length is greater than 0, which it is, and string at n-1, which is string at Y, is not equal to string at n-2, so not equal to Z, then append string at n-1. So we're going to append our Y. And then if temp length does not equal string length, which it does not, Then we're going to return, remove dupes, and then send in our string. So we're sending in azxzy. So our new string is azxzy. Okay, and this all starts fresh. Okay, so we go back in here, int n equals string length. So n is now 4. String builder temp is created, and if n equals 1, which it does not, if n equals 0, which it does not. So if n is greater than 1, it is, and string at 0 is not equal to string at 1, which it's not, then we're going to add our a. Now I is 1. So while I is less than n minus 1, which it is, then if string at I is not equal to string at I minus 1 or string at I plus 1, which that fails. So we just increase I, and we go in, and I is still less than n minus 1. So we're looking at our z here, and if we look left and we look right, it fails. So I plus plus now is 3 less than n minus 1. No, it's not. So we get out of the while loop, and if temp length is greater than 0, which it is, and string at n minus 1 is not equal to string at n minus 2. So if y is not equal to z, which that's true, then append. Okay, and then if temp length does not equal string length, which it does not, then we're going to return, remove dupes, temp to string. So now we're sending in our AY, and we start fresh. Now n equals 2. We've created temp, and then if n equals 1, which it does not, if n equals 0, which it does not, if n is greater than 1, it is, and string at 0 does not equal string at 1, which is true, then we append a. And then we have int I equals 1. So while I is less than n minus 1, well, n minus 1 is 1, so that does not hold true, so we skip the while loop. If temp.length is greater than 0 and string at n minus 1 does not equal string at n minus 2, if y doesn't equal a, which it doesn't, then we're appending. If temp length does not equal string length, and that fails as well because they are the same, then return temp to string. So now we're returning a y, which was converted into a string. So the complexity of this is, I would say, it's going through the string n times. But then if it goes through each time the recursion happens, it's going through smaller and smaller parts of the string. So it's kind of hard to calculate because it would be less than the string. But then it's also like worst case, I think it can only go through the string twice, the whole string, because of the recursion would stop if there's all the duplicates removed. But it would go through small parts of the string as it's removing. So I would say that it is probably like an O of, I would say like it's an O of m times n solution. So however many duplicates are removed is going to determine m. So that's probably the best way to represent that. And it's going to use a little extra space because of the string builder as well.